ICP students. Today we are going to be looking at the different forms of energy. So if you remember, energy was the ability to do work or the capacity to do work. And we talked about two types of energy, kinetic and potential energy. Now we're going to start looking at some forms, and we're going to look at 6 different forms of energy. Those 6 forms are mechanical, thermal, chemical, electrical, electromagnetic, and nuclear. Now, our first one is mechanical energy. So mechanical energy is associated with motion and position. Now, you may notice that contains parts of potential energy and kinetic energy. So kinetic energy is the energy of motion, and potential energy is based on an object's position or shape. So both of those combined turn into something called mechanical energy. Now we have this picture of a roller coaster up here because a roller coaster is an example of something that takes advantage of mechanical energy. So if you've ever been on a roller coaster, you know the train goes up to the very top of the hill. Now the reason they start by taking you up to a very top of a big hill is that when you're up there, your position gives the train a lot of potential energy. And so as you start coming down the opposite side, you start picking up speed because of all that potential energy being turned into kinetic energy. And that kinetic energy then allows you to make it up another hill and twists and turns and loop-de-loops, and then someone pukes. So that is mechanical energy. That takes us to thermal energy. So thermal energy is motion on a microscopic level, also known as heat. So when we look at thermal energy is caused by very fast movement of atoms, molecules, compounds. So when we think about like a stovetop getting very hot, the reason that stovetop is very hot is because those atoms around the burner are moving extremely fast, much faster than any of the other ones. And so when they collide, they transfer some of that energy to what they collide with, heating whatever they collide with up. So thermal energy is based on very fast movement at the microscopic level, which we would know as heat. Now, chemical energy is going to be more of like potential energy. Okay, it's the energy that is stored within chemical bonds. Now, when those chemical bonds start breaking apart, you can get the release of chemical energy, and it can usually turn into thermal energy. So when chemical bonds start breaking apart or releasing energy, you start to feel something warm up, or you get a fire occurring. Now, when we consume food, what we are doing is we're consuming that chemical energy. And as we need that energy in our body, we start breaking apart the chemicals that were in that food, and that energy that was stored in those chemical bonds gets released, which gives our bodies energy. That brings us to our joke of the day. And I apologize, I forgot to put the joke of the day on the last lecture from yesterday. So, what do you call a pig that knows karate? A pork chop. Chop, chop, chop. Pork chop. Ooh, that sounds good. Maybe I should make that for lunch. Who knows? All right, so that takes us to our next form of energy, electrical energy. Electrical energy is associated with electrical charges, so think static electricity, think of sparks, think electricity, lightning. So the difference between positive and negative ends creates this energy known as electrical energy. And electric energy can kind of correlate with electromagnetic energy. Electromagnetic energy is waves that are due to electric or magnetic fields. So this could be infrared, microwave, gamma rays, X-rays, ultraviolet, even visible light. All of that is due to electromagnetic energy. So here on the left side, we have listed the electromagnetic spectrum, which lists all of those things I've said, including a couple others. On the right side, you see the northern lights, which are caused by electromagnetic energy. And that electromagnetic energy just happens to be in the visible light spectrum. All right, that takes us to nuclear energy. So nuclear energy is the energy stored in the nuclei of atoms. So it's very similar to chemical energy, but it is much, much greater. So when you think about all those protons and neutrons in the nucleus of an atom, the energy stored there and holding those together is the nuclear energy, which has a very high potential for energy. That is why we have nuclear reactors, we have nuclear bombs. Nuclear reactors and nuclear bombs take advantage of the potential energy within nuclear energy by breaking apart the nucleus and releasing a ton of energy that was stored in the nucleus of the atom. Now, because so much energy is stored in the nucleus of an atom, it doesn't take many atoms to get electricity generated or to create a massive bomb. That is why nuclear energy is the choice for nuclear power plants and for nuclear detonations. So anyways, guys, that was kind of a shorter lesson today. If you notice, there was no math involved with today's lesson, which means today's assignment is not going to have any math problems. So anyways, go ahead. If you have questions, send me an email. Otherwise, go on to Canvas and start your assignment.